Hello there, exercise 7D. Looking today at trying to play around with exponentials and logarithmic functions again, but this time trying to solve a variety of equations that may occur with logs and exponentials in them. So we'll get cracking on this. It's something we definitely need to be able to do. So anyway, I've got a starter for you. I want you to pause the video in a bit and see if you can do them. Now, they're not necessarily easy, but we saw things which are similar in the last couple of lessons. So see if you can do them, and if you can't, I'm going to show you how to do them in a bit. So pause the video now. Okay, so hopefully you have paused the video and you have done them, but if not, here's what I reckon you should be doing on them. So this first one, you'll notice that it says log to the base 5 and log to the base 5. Now, because it's the same base log, we can join them together, and if you remember, the minus becomes a divide. So I'm just going to write that. I'll start up here if you make sure I've got enough space. Now the log, now notice I'm doing x plus 3 over x, so a minus becomes a divide, equals 2 obviously. Now I'm going to move the log onto the other side, and when I do that it becomes an exponential. So I get x plus 3 over x. Now we've got to be a little bit careful here. I suppose there's two things you could do. You could do 2 to the 5 or 5 to the 2, and you've got to know that it's this base number here that becomes the base number here of the exponential, and that's why it's 5 squared and not 2 to the 5. 2 to the 5 would be wrong. I don't know what happened there. So obviously 2 to the 5 squared is 25. So I'm going to write x plus 3 equals, and I'm going to move that x over as I do it, equals 25x. I move the x over again, I get 3 equals, well, I've got 25x there. I take away that, it's 24x. So I reckon x is 3/24ths, or if we simplify that, 1/8. Hopefully you can see where I got that from. Now what's this next one got me to do? Well, it's to the base 9 this time, but now with a plus. So I want to do it really exactly the same way. I'm going to say the log to the base 9 of, well, it's now the 2x plus 11 times by, what is it, x minus 2. And what's it equal? Equals 1.5. Okay. And I can join these two things together. I can say, well, sorry, I have joined them together already. I can move the log onto the other side. That's probably better. But as I do it, I'm going to multiply out these brackets this times. So if I multiply that out, what do I get? I get, I don't know, I'll put it in a bracket, 2x squared minus 4x, sorry, plus 11x, so that's plus 7x, minus 22 equals, now again, make sure the base here becomes the base here, 9 to the 1.5. Now, this then becomes a quadratic equation, 2x squared plus 7x, 9 to the 1.5, well, that's the equivalent of 9 to the 3 over 2. So if you do it on your calculator, you'll get 27. And I'm going to move that 27 over, and I get minus 49 equals 0. So I need to type these into my calculator. So menu, go to the A, and solve these polynomial of degree 2. So what is it? It's 2x squared, 7x, and minus 49. And that, hopefully, yes, it's given me a nice answer. First one at least, x equals 7 over 2. And there should be two answers. Let's see what it is. Oh, now it says x is minus 7. I'm saying because equals minus 7, sorry. The reason why I don't like that, let's write it properly. The reason why I don't like that is because negative, you can't log negatives. And yeah, look, this was what I was fearing. Now, if I put minus 7 in there, minus 7 minus 2 is minus 9, and you can't log minus 9. So that is definitely not a solution. Now, the other one, 7 over 2. 7 over 2 is 3.5. Now 3.5 minus 2, that's okay. I can do that. So that's not a problem if I put 3.5 in there, and obviously that's okay as well. So I think this is a proper solution, but the other one isn't. This one now. Alright, now first of all, you'll notice it's got a 3 on its own, which I suppose I could do in a similar way to the ones I've done with the other ones. So if I was to move that way and that way, I reckon I could write the log to the base 2 of x squared. Notice I've moved the 2 up as a power. Minus the log to the base 2 of 14x minus 3 is equal to that negative 3. So what's that give me? Well, that gives me the ability to now multiply them together. Of x squared times the 14x, well, I might as well just times it. So, oh, this is a divide. Oh, I nearly got it wrong. X squared over 14x minus 3 equals negative 3. So now I can move the log to the other side. X squared over 14x minus 3. And notice it becomes, the base number is 2 to the minus 3, which is an eighth. Now if I multiply the 8 up, I get 8x squared. If I move that over there times by the 1, I get equals 14x minus 3. So presumably 8x squared minus 14x plus 3 equals 0. And let's see what answer that gives me. So exactly the same, I've got it on the screen already, so just type it in 8, negative 14, and 3. And I get 3 over 2. So I get x equals 3 over 2. There's one answer. What's the other answer? Oh, a quarter. So no negatives here, so that's, let's see what I have to do. Oh, I have to do a negative here. So 14 times by x. Now, times by this is fine, because 14 times 1.5 is a huge number when I'm taking away 3. 14 times a quarter, I think, is 3.5. So take away 3 is still okay, it's not negative. And that's so both of these answers I think are okay. The last one's an exponential equation, so let's solve the exponential. I've got 5 here, so I'm going to move that exponential over, it will become a log, so it will give me 2x minus 7. This was to the base 5, so it becomes a log to the base 5 of 200. So let's do that. So it's relatively simple, this question. Menu 1. So log to the base 5 of 200. I've got to add 7 and then divide by 2, 5.15. So I get x equals 5.15 to 366, which is what it said at the top. So that's right, that's right. That's right, that's right. So I'm happy with those. Anyway, on to the main questions then. So notice these now are exponential disguised quadratics. Now, notice this power is double this power. And it's for this reason I can do it. So notice the power is double that power. And that's really what we're looking for in disguised quadratics when they're exponentials. So I'm going to start here. I'm going to have y equals 5 to the x, the middle one. And just for reference, therefore, y squared is 5 to the 2x. This is why we can do it. So this becomes y squared. 3 times y plus 3 times y minus 10 equals 0. That is what we're looking for. So chuck it into my calculator and menu. I have to go to A again. And what is it? I've got 1. I've got 3, and of course you get this one. This is a relatively easy one to factorize, but I just went through the motions of doing it. That gives me y equals 2 and y equals minus 5. You might want to pretend you've done it properly by just sliding in here y minus 2, y plus 5. If one of those questions which said show detailed reason, you'd show that. And because it's y, of course, it's not really y, it's 5 to the x. So therefore 5 to the x is 2, or 5 to the x is negative 5. 5 to the x is 2. Now remember what you're doing. You're effectively moving this over. It becomes a logarithm. So x is base 5, so it's log to the base 5 of 2. And this says x is log to the base 5 of minus 5. And notice what I've said before. You can't find a logarithm of negative numbers. So when I try to do this, it's no real solutions. Okay. And essentially it's because these exponential graphs are never below the x-axis. So the actual graph would look like that. And we're saying, when's it equal to minus 5? Well, the answer is it's never equal that low. Anyway, so this is the answer. I'm going to chuck that in. It said 3 significant figures. So I want menu 1. So I want log to the base 5 of, what is it, 2. 0.431. I think that's my only solution. Yes, it is. Next one, find the exact solution to this. Now, look, this is a bit trickier. Now, straight away, you'll notice it doesn't say. See, last time when we did it, it was 5 to the 2x, 5 to the x. Perfect, no problem. Now it's 4 to the x, 4 to the 2x. Not so easy. But it's relatively nice because 4 you can write as a power of 2, and that's the trick. So because 4 is the same thing as 2 squared, I can write this as 2 squared the power of x. And I've picked my lower number to play around with. Plus 2 to the x. I'm going to move the 12 over. I know I'm going to need it over there. Equals 0. And why is that useful? Because really that's 2 to the 2x. Plus 2 to the x minus 12 equals 0. So set it equal to the middle one again. Y equals 2 to the x. Therefore this is y squared plus y minus 12. And this time I'm going to factorize. I'm going to say y plus 4, y minus 3 equals 0. So y equals negative 4 or y equals 3. Now notice what I've said. These things are really not y's, they're 2 to the x's. 2 to the x is negative 4. 2 to the x is 3. But this has no solutions. We've already seen that exponentials don't give negative answers. So this one we can. X is to the base 2 of 3. No idea. Oh, it says the exact answer. It actually wants that then. There it is. Okay, like that. I've written it in an alternative way there, but that's what I would write now. Solve this. Now you've got to be aware of what this means. 3 to the 2x plus 1. Let's get our head around it. It's 3 to the 2x, but because it's plus 1, it's times by 3 to the 1. And why is that useful? Well, if I write y equal to the middle one, 3 to the x, then this thing here becomes, because it's 3 to the 1, it's 3 times by, I've got 3 to the 2x, well I know that will be y squared. So it's 3 times y squared minus y minus 24 equals 0. And if you can get that information out of this, by the way, if it said 3 to the 2x plus 2, I would have had to say it was 9y squared, because 9 is the 3 squared. But it doesn't, it says this, so I'm going to type it into menu A, sorry. So I've got 3y squared, I've got negative 1y, and I've got negative 24. I'm sure that factorizes very nicely. In fact, it does. It tells me that y equals 3, and what's the other solution? Minus 8/3. I'm guessing one of them isn't going to work. So 3 to the x equals 3. So therefore x equals 1 if you log it. It's fairly obviously 3 to the 1. But this one, no solutions, because you can't log negative numbers. And that's it. We've run out of questions, actually. I thought there was going to be a few more, but that's all the questions I've got for you. So just have a go at that. Just see how you go. Logarithms and exponentials do come up in equations. We do have to get our head around them. And hopefully we will be a little bit better at them after doing this exercise.